Hello students, today I'm going to demonstrate how to solve an equation that contains a radical. This particular radical is a square root because the index is a 2. If there's no index present, it's understood to be a 2. All other radicals have to have an index present, like a cube root, there would have to be a 3. A fourth root would have to have a 4. But square roots, they don't have to have their index listed. It's just understood to be there. The first step in solving a radical, or an equation that contains a radical, is to have the radical by itself on one side of the equation. This particular equation, that's how it already is. To undo the square root, we simply raise it to the power of that radical's index, which is 2. But if I raise this side of the equation to the power of 2, I have to raise the other side of the equation to the power of 2. This results in a binomial being squared. On the left-hand side, the outer exponent simply undoes the radical. So everything on the inside of the radical simply comes to the outside. On the right-hand side, I have to multiply that. I could write that down twice, and I could do my FOIL, my first to first, last outsides, insides, last to last, the distributive property twice, however you want to look at that. Or if I remember my shortcut, I can simply take the first term times itself, the first term times the last term times 2, and then the last term times itself. Now that I've gotten rid of the radical, I have to solve for the variable x. Notice that my highest degree is x squared. That means I'm going to end up with a quadratic. When I'm solving a quadratic, I have to have a 0 on one of the sides of the equation. Since my left side only has 2 terms, I'm going to go ahead and move both of these to the other side of the equation by adding the opposite. But if I do it to one side, I have to do it to the other side. So if I'm subtracting 44 from here, I have to subtract 44 from the other side as well. If I'm adding x on the left, I have to add x on the right as well. Whenever you have an equation, you have to do the same thing to both sides to keep it equal. Now I have a quadratic equation, x squared minus 3x minus 40. Now that it's set equal to 0, I can solve this particular quadratic equation in several different ways. My personal preference is to factor. I'm going to look at my very last term, which is a negative 40. That negative sign tells me my two binomials will have different signs. My first sign tells me that my larger factor is going to be negative. I'm looking for two factors of 40 that subtract to get 3. Sometimes I can just spot the answer, but if I can't, I'll make a list of factors of 40. 1 times 40 is 40, 2 times 20 is 40, 4 times 10 is 40, 5 times 8 is 40. I'm looking for a pair of factors that subtract to get 3. Or I could say a pair of factors of integers that add to get negative 3. Integers can be positive or negative. So in this case, I know my larger factor is negative, and I know negative 8 plus 5 gives me negative 3, which is the middle number. So I simply separate my first term, and I put my 8 where the negative is, and my 5 where the positive is. If I wanted to mentally boil this back, I could. X times x is x squared. 5 times negative 4 is negative 40. My insides, that's 5x, plus my outsides, which is negative 8, gives me negative 3. So I know that's correct. Now I have to set each factor equal to 0 so I can solve for the letter. So I have x plus 5 equals 0, and I have x minus 8 equals 0. I have to add the opposite. So I get x equals negative 5, and x equals positive 8. Now, whenever I start with with an equation that has an even index, I have to check my answer. I can't just trust that these both are going to work in that original equation. So just because I've solved for my letters doesn't mean that I'm done with my mathematics to find the answer or the solution to this equation. I'm going to plug in the -5 into the original equation. And I'm going to determine if both sides really do equal. My left side simplifies down to +7. My right side simplifies down to -7. They do not equal, therefore -5 cannot be a solution to this equation. Now I have to go back and try my other value that I found. Just because this one didn't work doesn't mean that the other one will work. Sometimes they both don't work. You always have to check your answer if your original equation started with an even index. But notice on this one, both sides really do equal. Therefore, I can conclude the solution to this particular equation is x equals 8. I hope this was helpful. Have a great day.